The sun has sustained the Earth and fascinated humans since the beginning of time. And as our understanding of physics and our space technology have advanced, so too have scientists tried to tackle more questions about the sun and its effects on the Earth. One baffling matter has to do with the temperature just outside the sun's surface.
It's a long-standing mystery in plasma astrophysics of how you create a very hot corona, a millions of degree corona, from a cool star.
Many of us know that the sun's corona, its atmosphere, is extremely hot. But maybe what's not so commonly known is that the actual surface of the sun is surprisingly much cooler than the corona.
To really understand the plasma physics behind this, we have to go there directly and make measurements, and that's the mission of Solar Probe.
Launched in 2018, NASA's Parker Solar Probe spacecraft has now traveled closer to the sun than any other mission in history, actually penetrating the sun's atmosphere to investigate its highly charged magnetic field.
Here at Berkeley, we have the lead responsibility for one of the instrument suites, and we have a major role in one of the other instrument suites as well. We designed, we built, and we operate the bulk of the instrumentation on the spacecraft.
Those instruments are measuring the properties of the solar wind, that rush of electrified particles the magnetic field continually pushes out towards the Earth. Understanding the solar wind could inform the key question of the hot corona, and also help us prepare for major disruptions the wind can cause to our spacecraft, satellite communications, and the safety of our astronauts. Named after Eugene Parker, who developed the solar wind theory, the probe has already sent back many interesting measurements.
The first 3 encounters of Solar Probe that we've had so far have been spectacular. We can see the magnetic structure of the corona, which is an important thing. It tells us where the solar wind is emerging from. We see impulsive activity, large, what we call jets or switchbacks, which we think are related to the origin of the solar wind.
The probe also captured information about solar dust, tiny remnants of disintegrated comets or asteroids.
We're able to measure dust impacts on the spacecraft, and we're surprised at the kind of ferocity of the dust environment in the inner heliosphere.
Built with the most sophisticated heat-protecting shields of any other spacecraft, the probe stays cool with a novel water circulation system that captures and expels the heat into space. It's also the fastest spacecraft in history. At 430,000 miles per hour, it could take you from New York to Tokyo in less than a minute. But it's clear that the best thing about the mission is all the new knowledge it's generating.
We've been working essentially around the clock for a decade on this thing. And so to see this data, it's just a pleasure. I mean, the data is so spectacular. It's a big case of delayed gratification, but it's really terrific stuff. I think we're on the cusp of being able to answer the question of what heats the solar wind.